Sea ice, frozen water that forms, grows, and melts in the ocean. It should not be confused with glaciers or icebergs. Since 1972, scientists have been using satellites to measure sea ice extent, area of ocean with at least 15% sea ice coverage. Sea ice thickness and the extent of summer sea ice have been declining dramatically since the 1980s. In the Arctic, sea ice is a major force in keeping air temperatures cool and overall moderating the global climate. Changes in the amount of sea ice alter how cold the poles are, which can affect the atmospheric and ocean circulations. Because of this, the Arctic is very sensitive to climate change. The surface of the sea ice with snow cover has a high albedo of 0.8. This means 80% of the sunlight that strikes its surface is reflected back to space, with only 20% of it absorbed. In areas where the ocean is exposed, the surface is very dark, almost black. This has a very low albedo of 0.1, which means when there is a lack of ice coverage, 90% of the sunlight is absorbed by the ocean, raising the ocean's temperature and changing the planetary radiation balance. This will enhance the regional and global warming process. This warming of the ocean's temperature will also cause thermal expansion to occur. And since warm seawater has a greater volume than cold seawater, the total volume of the ocean will increase, causing the sea level to rise. Also, as atmospheric temperatures go up more and more, ice and snowfields will melt, increasing the amount of water in the oceans and therefore causing the sea level to rise faster than by thermal expansion alone.
Over the past century, the global mean sea level has risen by 4 to 8 inches. While it is hard to pinpoint how much the sea level will rise, most predictions agree that the oceans will rise somewhere between 2.5 to 6.5 feet by 2100. An increase in storm surge is another aspect of sea level rise that will affect low-lying regions. Rising sea levels will make it more favorable for smaller storms to cause huge amounts of damage with storm surge, and larger storms can make the 100-year flood occur every 5 to 10 years. Warmer ocean temperatures will likely help strengthen some Atlantic hurricanes, so while there might be fewer hurricanes, they will be stronger. Sandy is a great example of all these aspects coming together. Abnormally high sea surface temperatures in the Atlantic helped intensify the storm, as well as allowed the storm to stay strong after it left tropical waters. The storm surge with Sandy occurred at high tide, which is a good example of what normal storm surge in the future could look like. Low-lying areas around the globe will also be threatened by beach erosion, landslides, and contamination of freshwater supplies. So what is being done to cope with rising sea levels? In Louisiana, the levee projects are being designed to anticipate an increase in sea level over the next 100 years. The problem, though, is Louisiana is sinking as sea levels are rising. Regionally, the sea level has risen 8 inches in the last 50 years, slightly faster than twice the global rate. In the United Kingdom, the Thames Barrier was built to protect London from flooding due to exceptionally high tides and storm surges. The barrier was designed to withstand floods that occur only once in 1,000 years. Both rising sea levels and more extreme weather, the barriers need to be redesigned. Melting sea ice will change our planetary radiation balance, causing ocean and atmospheric temperatures to rise as well as sea level. By 2100, the oceans could rise another 3 feet, causing storm surge and flooding to become more powerful and destructive. Many cities are already starting to prepare for this fate, but it is still unknown if this will be enough. For Up in the Air, I'm Catherine.
I'm Lacey.
And I'm Corey.